So this is just a continuation of 1413. We're trying to name epoxides. The first step is to find the backbone. The backbone is going to be the longest carbon chain you can find without going backwards or lifting up your pencil. And so here, if you go left to right, you get 5. Even if I didn't go all the way to the right, if I went down, for example, I'd still get 5. And so 5 seems to be our longest chain. So that's going to be our backbone. I'll circle that so it stands out from any of the branches. And so here, if we wanted to name this backbone, before we think about the branches, we have 5 carbons. The prefix for 5 carbons is pent. In that chain, we have all single bonds. So the infix is AN. And in that circled area, we only have carbon and hydrogen, so the suffix would be E for a hydrocarbon. So that is our backbone. Now let's think about the branches. We have this oxygen branch, this epoxide branch, where you get an oxygen coming off and immediately going back onto the chain in that 3-membered ring. The name for that is epoxy. And if you number this left to right, you get the lower number for this functional group, the ether. And so you would want to number it left to right for that reason. So you'd have 2, 3. This is attached to 2 and 3. 2, 3 epoxy. That would be the name for that branch. And if you look at your other branch right here, it's coming off of carbon 4. There's only 1 carbon here. The prefix for 1 carbon is meth. And if you ever have a carbon branch, immediately after the meth comes or the prefix comes a YL. That tells you this is a carbon branch. So here we have our names. We've got the branch name, the backbone name. Now, pentane comes last. The epoxy is an exception, even though the E comes before the M, and you usually order branches alphabetically. Even though these epoxides are an exception, they're so closely tied to the backbone that the name comes immediately in front of the backbone. And then the other branches go in alphabetical order in front of that. We only have one other branch, it's 4-methyl. So far we've got 4-methyl-2,3-epoxy pentane. And that would be the whole name, except we have chiral centers. The big tip-off are these stereochemical bonds. And so we should consider each of these 2 atoms. So I'll use this one, but first let me draw this molecule one more time. This way we can think about both chiral centers on a clean drawing. Okay, so this is what we have. Let's think first about the left chiral center. Now, whenever you want to assign R or S, right or left-handedness, to a chiral center, the first step is to assign priorities to the 4 things bonded to that chiral center. Oxygen has and you do this based on the atomic number. So oxygen has an atomic number of 8. Carbon, which is both on the right and on the left, has an atomic number of 6. And this already has 2 bonds in the plane, one coming out at you. So the 4th bond here is going to be going away, and because nothing is written, that bond is going to be going to an implied hydrogen. Hydrogen has an atomic number of 1. That's the number at the top of the box on the periodic table. And so immediately we know this oxygen has the highest atomic number. It's going to get the highest priority of 1. The hydrogen has the lowest atomic number. It's going to get the lowest priority, 4. And the 2 carbons tie, so we'll want to make a table for each of those. A table for the carbon on the right, a table for the carbon on the left. This carbon on the left is a methyl group. It's really just bonded to 3 implied hydrogens. And so we can put that in this table. The carbon on the right, this one, is bonded to an oxygen, a carbon, and an implied hydrogen. And notice that I ordered those in the table in descending atomic number. First oxygen, highest, then carbon, then hydrogen. So when we compare these 2 carbons, we're going to compare the tables, and we only look 1 row at a time. You don't look at the whole thing. Just look at the top row. Only if those tie would you go to the next row. But they don't tie. Oxygen has a higher atomic number than hydrogen, and so this carbon will have a higher priority than this carbon. So this will be a priority 2, and this will be priority 3. So once you have your priorities, you want to check to make sure that the thing with priority 4 is going away. Lo and behold, it is, and if that's the case, you can ignore 4. We talked about what to do if that's not the case in B here, so if you want to know about that, I would encourage you to go watch the video for B. Alright, so we have them named, we know 4 is going away, we go from 1 to 2 to 3. That is clockwise, and because it's clockwise, it is right-handed. Just like if you go from the top of an R down, you have to go clockwise. So this is R, and so we numbered this. We numbered it left to right, right? 1, 2, 3, 4, 5. We just found the chirality for carbon number 2, and so this will be 2R. We'll put that in parentheses, at the front of the name. Okay, so much for that chiral center. Let's think about the other chiral center, this one right here. And we would know, the tip-off that that might be a chiral center would be this here. And if you look at it, you'll see that carbon is bonded to 4 different groups. One of them being a hydrogen, so hydrogen is going away here because you already have 2 bonds in the plane and 1 coming out. Okay, so we want to assign priorities. This is bonded to an oxygen. Oxygen has an atomic number of 8. Bonded to a hydrogen. Hydrogen has an atomic number of 1. And to 2 carbons. Each of these carbons has an atomic number of 6. Oxygen has the highest atomic number, so it's going to get the highest priority of 1. Thank you, 8. The hydrogen has the lowest priority, so the lowest atomic number, so it's going to get the lowest priority of 4. So now we have the 2 carbons. Those tie, and so anytime you have a tie, you want to make a table. This carbon here on the right is bonded to 2 carbons and an implied hydrogen. So carbon, carbon, hydrogen in order of descending atomic number. The carbon on the left is bonded to oxygen, carbon, and an implied hydrogen. So those are the 3 things you'd want to consider there. Let me redraw those in. Okay. So we have our 2 tables. You want to compare them 1 row at a time. Only if a row ties would you go to the next one. Compare an oxygen to a carbon. The oxygen has a higher priority than the carbon, so this carbon will have a higher priority than the other one. This carbon will be 2, and the other carbon will be 3. Okay, so once we have the priorities, check to make sure 4 is going away. Lo and behold, beautiful, it is. And so if it is, you can ignore 4. Go from 1 to 2 to 3. This is counterclockwise. And so because it is counterclockwise, it's going to be S. Just like if you go from the top to the bottom of an S, you have to go counterclockwise. If you remember, this was carbon number 3 that when we numbered it, we went from 1 to 2 to 3 to 4 to 5. This was carbon number 3, and so on carbon number 3, we have an S. So we have 2R3S4-methyl-2,3-epoxy pentane. We earned that name. That is the name for this compound.